Okay, in this question, again, you've got a lot of information to take in. This is the reaction that we are carrying out, and what you can see is hydrogen gas is being produced. Take your time looking through the information. They are how the mass has changed during this reaction. Just remind ourselves, so the mass here is starting to decrease, is how much it's being lost, and eventually it will level out, so the mass doesn't change. So here the mass is no longer changing because the reaction has actually stopped at this point. Let's get on to the questions. So how could we measure the volume of acid being used? So you would normally use a measuring cylinder to record the volume. Explain why is a loss in mass. So you are forming hydrogen gas. So hydrogen gas is produced, and this gas escapes from the container. Okay, the graph shows the reaction is slowing down. Explain using particles why it starts to slow down. So here I've done a little diagram to show you the start. And at the start, we've got lots of particles present. And what happens is the red and the blue have to find each other in order to react. And once they've reacted, they are no longer present in the mixture. So over here, if I come back to these ones, this means there are going to be fewer particles left and therefore fewer chance of the reactions of colliding and reacting. Okay, so I think there are 3 marks here. There are. So there's 3 marks here. So we need to say that there will be fewer particles left as they have reacted. And if there's fewer particles left when they've reacted, there is a less chance of successful collisions, and I think that's going to get us all the marks there. Less chance of successful collisions. Okay, so marks for this, you're going to get 1 mark for stating this, 1 mark for saying last chance, and then of these types of collisions. Okay, 3 marks for your answer. The experiment was repeated using high temperature. All the conditions were kept to explain why high temperature on the mass. So if we have a higher temperature, then the reaction will happen faster, so the loss in mass will be greater. So loss in mass will be greater. The original experiment was repeated using the same mass but in powder form. Sketch you'd expect. See, remember powder has a larger surface area. And if you have a larger surface area, there would be more chance of successful collisions taking place, and therefore the reaction should go more quickly. So it'll lose mass more quickly. So here, if it's losing mass more quickly, it'll be steeper at the beginning, but it will still lose the same amount of mass that we had before. Okay, I think there are 2 marks. So you get 1 mark if you drew it to the left of the first, and you get a 2nd mark for doing it so it ends at the same point. Remember to make this nice and smooth. No bumps, no wiggly lines in there. Okay, state the effect of a catalyst. So catalyst on the reactions. So catalyst speed up a reaction. So it'll speed this reaction up, and devise a simple experiment to find out what happens to the mass. So all you'd have to do here is weigh out a mass of the catalyst, weigh out a mass of catalyst. You then let it to react, leave it to react, and once it's done its reaction, you would remove the catalyst from the container. So here we would remove the catalyst once the reaction has finished, and before you would weigh it, you would just dry it. So we put in here, dry the catalyst, and you would then reweigh it. Okay, and you can compare the mass before and afterwards, and the mass, remember, should be the same.